Who was gone last time? Were you able to find the video?
On Canvas? Have you gone to Canvas? I didn't post it on 9 until like, I was scheduled at 7:30, so it was probably a late evening when I posted the video. But it was there. Okay, today we're going to talk about rate of change and tangent lines. Both of these phrases you should have heard of before. Does anyone know a synonym for rate of change? Slope. What is a tangent line? Have you heard that before? Remember what it is? Right, let's find out, right? Okay, so here's a question. What are some ways and differences between average rate of change and instantaneous rate of change? There are some confusing things for students, okay? There are some confusing things you'll see through the data that the phrases are so similar that they mean different things. We use the word average a lot. Average rate of change, average velocity, average acceleration. And they mean do something different. They all have the word average in them. That doesn't mean you have to be divided by 2. Okay? Also, instantaneous rate of change is different than average rate of change. So, we pay attention to the terminology to make sure you know the difference. Okay, so, if you know the average rate of change, you already told me slope. What's another way to write slope? Rise over run. Rise over run. What else? Okay, there's the equation on that. N equals, I think this is first, we do always say y2 minus y1 over x2 minus x1. Okay, you think about this? A great symbol. Delta limit. It is change of y, which is y2 minus y1, over change of the x, or delta x. Okay? Delta has our word this one. So delta has the letter x. Doesn't that mean slope? Chris. What are you about, Chris? Okay, there's 2 more. Let's take a physics. Take a long physics. Run. B. And velocity. Velocity. Now, it's hard to get slope on the velocity. The velocity of the position, yeah. The slope of, actually I just said, I think I said that wrong. But I'm going to go actually, I'll get to it. One more that I'm new to, derivative. Woo, come on. 3.1 and derivative. We're exciting stuff. Derivatives. You probably heard that before. Calculus has derivatives and reciprocals. And intervals, right? Not the intervals, that's what I'm doing. Okay, so those all need slopes. So when we're saying I'm a derivative, actually doing slope. Okay? Average rate of change. Average rate of change is over an interval. Over an interval. We have a graph that actually in y2 minus y1. We used this when we were looking at the intermediate value theorem when we did the graph. Remember that IDT, summary, on a continuous function on a closed interval a to b, this is what we did last time. On a closed interval a to b, what is the y value of this a? Okay, thank you. That is the y value of this b. Now for b, it says I was trying to get out of you is the FB is a rotation on the y-axis. So we have y2 minus y1. We have the first point A and the first point B are y. Subtraction will be f of b minus f of a. Divided by b minus a. F of b has f of a divided by b minus a. Because f of b and f of a are on the y-axis, b and a are on the x-axis. Okay, and this creates a secant line. You know what a secant line is? Well, I don't know what we call opposite. Secant line can go through things. If I connect from A to B, it's finding the slope between those two points. It doesn't go through things. That's a secant line. Okay, a tangent line. A tangent line is a limit. Okay, the limit as h goes through. That's not very much space. The limit as h goes through 0. We've done limits, right? As it approaches 0, this is the definition of a limit. F of x plus h minus f of x over x plus h in parentheses minus h. Okay, this will make sense once you look at the graph. That is our tangent line, which is different at the line. It's x. Keep that in mind. Yeah, goes to 0. Now I got all those O's. Okay, so average rate of change, and if we have a point A and a point B, it's the secant line from there to there. And connect them, average rate of change is the slope between those 2 points. Okay, I think we'll be doing, we'll do graphical tangent line on the next page, so we'll just worry about that right now. So on this picture over here, if I wanted to find the average rate of change from driving 1 hour to 2 hours, then I'll move my graph. How would I demonstrate the average rate of change from 1 hour to 2 hours? I do that. Obviously, the line, the first point to the second point is the slope. From the first point to the second point, the slope of that line, the secant line, we are average rate of change. Because if I mathematically, you can think of it, my M's and my M's are not what I say. You can think of it as y2 minus y1 over x2 minus x1, but the quicker to do it, f of b, which is our second point, minus f of a, over b minus a. Can you find the average rate of change of that graph? And put units on it. Which everyone else should put units on it. This graph right here. Okay? So you get the information you need off the graph. See this one? I would get a change from that point to that point. change is 20 what? Miles per hour. I should really put MI, because I usually like meters. Miles per hour, MPH is also, I think that's acceptable for miles per hour. So I don't want to put MI. Okay, let's look at number one. Find the average. Notice these are bolded because the next page I'm going to change the word to instantaneous. Average rate of change, instantaneous rate of change. So pay attention to the details of what's being asked. Average rate of change, we have a square root function. It's already drawn on the next of it. Can you find the average rate of change from the interval 0 to 2? So we can do f of, what's the second point? What's ending x on the interval? F of 2 minus delta of 0 all over 2 minus 0. Okay, from the correspondence questions on the AP test, you get points for every step. So this is one of the steps is writing, and you want to tell how the rate of change is when you put in 2 and 0. That gives you a point. So write it all out, and then solve work. I put in the 2. Minus putting in the 0. All over 2. Step by step, show the work. Equals, what do we get under here? That's the root. 9 minus 1, square root of 1. So 3 minus 1, we get 1, right? I don't think we know miles or anything like that. Okay? Any questions about those? We can see what? Oh, this is a nice one because they're actually whole numbers, but they're decimals. And you can never rely on just visualizing the graph, but that's actually what that is. What if the point was, instead of at the kilos height, instead of 3, that was actually 3.1 by looking at the graph. But it looked like it was 3. So I had to put that into the equation to be safe. We can do both 2 and 3. And then when you're not checking your neighbors, if they have the same. A is the beginning of your interval, B is the end of your interval. So please set up the formula at the beginning. This one was beautiful on your test. Putting in your B value, putting in your A value. this and this. But I am more of a visual person, so whenever I come across sine and cosine, I just give myself a little squiggle. If I'm doing sine, I do this. Because what's right here? Shape pi, what's right here? Pi, and I know 1 to negative 1 on the regular parent function. If I was doing cosine, how does it start? Got 1, and it just looks like this. Right, there's my 2 pi, so what's the value of pi? Negative 1, and that's 0, positive 1. So, I don't want to be memorizing everything that's on that table on your gold trig formula sheet. But if I just do a squiggle, I can remember by looking at the graph. Okay. I think I see those people with, what is that, number 2? What do you get for number 2? So negative pi is the same as negative 2 over positive pi? Yeah, it's exactly the same. Okay, if you have questions on number 2, then you go over number 2. The answer is negative 2 over pi. Or 2 over negative pi would be exactly the same. Is that okay there? What are we getting for 3? 3 is 3. Any questions on how we get 3? Okay, let's move on to the next one. Look over. Here we go. Okay, instantaneous rate of change. We have been doing the average rate of change, and with average, we have 2 numbers, you just add them up and divide by 2, right? So it's add something and divide by something. That's over the span of time. Instantaneous rate of change happens at an instant. 1 point, not 2 points. 1 point. Okay, so that's what a tangent line is. A tangent line hits. You know this? Yeah, a tangent line hits the graph once and bounces off. Let's see, do I have, yeah, you have it right here, right? But then as h is approaching 0, we mentioned this on the front page. This is a definition of our tangent line. Okay, f of x plus h minus f of x divided by the same, right? X plus h minus x. It's just like x plus h is the mean minus x is the a. Does that sound pretty similar to the average rate of change? Divided by the b minus the a. The only difference is we have the limit in the middle, or in front. Okay, so we have this graph over here, saying this right here is where x is. X plus h is further out. X plus h is over here, right? Because x, and then further out is we added something to it. Does that make sense? X plus h is to the right. We're saying, like right now, that is a secant line. But really what we want to know is the slope at the instant, right here, just at the instant. Just where's x and x? What's that slope? But we can't just find a slope right at that point unless we can zero down on a bunch of secant lines. What if h, this gap, x and x plus h is called h. What if h went to 0? Meaning that gap got smaller and smaller and smaller. So see it out here, I now look here. Is that secant line slope changing to the first secant line slope? Yeah. What if we got closer and that gap became even smaller? The gap came between x and x plus h. What if h is smaller and smaller? Is my secant line slope changing? I can do it all day. And it looks like I'm in science. It's all. Here, so close. on your slope? Is it flattening out? Which actually makes sense because at the bottom of this, at a minimum, they're flattening out. So slope should be pretty close to 0. So when I'm finding a tangent line where the instantaneous rate of change, when it hits it at an instant, we can find exactly at the instant, but we can find like as it's approaching. That gap between 2 points is getting smaller and smaller. This h is the gap. Does that make sense? If h is the gap between the 2 points, as that gap goes closer and closer to 0, they would have the slope of a tangent line. So h is the gap between the b and the a. So it gets closer and closer to 0. Okay? So, let's not do up above. Let's just do this number 4. Find the instantaneous rate of change that is quadratic at the point x equals 4. So we're going to use the definition. The limit as h approaches, what do we want that gap to approach? 0 of f of x plus h. By the way, if you have large handwriting, you might want to walk where it's small. This is going to take 1, 2, 3, 4, 5, 6, 7 sets of limits. Okay? So that's small if you have large handwriting. F of x plus h minus f of x, because that's saying the change from f of x plus h to f of x over x plus h minus x. You might have broken. Okay, let's plug in. The limit as h approaches 0. This is called the function of function. We did this earlier. Remember turkey and stuffing? Yeah, the turkey is f. The stuffing is x plus h. Above it, we know f. F is 2x squared minus 1. So we're going to write 2 parentheses squared minus 1. What goes in the parentheses? What goes in the parentheses? X plus h over x is the number. 4. 4 plus h. Because we're going to have the x value 4. Minus f of x, that was the original function. Minus put all in parentheses. 2x squared minus 1. We're minusing all of it. All over. Yeah, actually, we need to change the x to 4. All the x's should be 4s. Wait, one sec. All over x plus h. Well, the x is going to be 4 plus h minus the x. So we'll do the x again. 4s. All the x's should be 4s if you know that instant you're looking at this. No. We don't know that h is 0. We're approaching 0, but h is not 0. We're trying to get smaller and smaller. Okay? So let's simplify this. Here we get limit as h approaches 0. Do parentheses first. Oh, actually, here's a song, right? 4 plus h squared. How do we square out binomial? First we square the first one. Square the last one 2. In between the first and last is 4 times h times 2, right? First times last times 2. So plus 8h. That's squared. Looks like it's on the parentheses, but it's inside. Minus 1. Minus all this stuff. What's inside the parentheses? We have 8 squared, or 4 squared, which is 16, times 2. 32 minus 1. Okay, so I'm going to save some room. I'm not going to extend that to reduce to that one in one step. Okay, 31 all over. What happens to the denominator? The 4's cancel. We want that. We want only an h in the denominator. Okay? Now let's see what we have left if we distribute everything true. Distributed are 2. So we have 32 plus 16h plus 2 if we try to do the limit and we plug in 0 for h, can I do that? Why not? Division by 0. Yeah, right? You can't divide by 0. So everything without an h should cancel out because everything we need with an h we can factor out the h. That's the next step is to factor out the h. So we have 16h plus 2h squared remaining, and then factor out the h. We're going to do a 16 plus 2h inside. The h's cancel. Once we cancel those, can we plug in a 0 or a limit? Yes, and you should be writing a limit every time until you plug in. Once you plug in, then you can drop the limit and just do 16 plus 2 times 0 equals 16. What in the world does that number mean? What does that number mean? What have we just found? Instantaneous rate of change could be more specific. A slope at x equals 4. Now that instant on, this one's not graph, but on that quadratic function, at that instant on wherever x is 4, oops, put the dead there, that slope right there is 16 at that instant. The slope is 16. We know quadratic, the slope is always changing, right? And the curve is always changing, but at that instant, at x equals 4, the slope is 16. So make sure you understand what this answer means. Okay, we're going to try this one by yourself. Okay, a few reminders. You don't have to write this every time. You can start with this step. However, make sure you replace all of the x's with the instant. What's on next? I'll put your x's. With whatever x we're looking at. So you're going to find the instantaneous rate of change at x equals 3. Okay? Plug into this formula. I think the trickiest part is just the setup. Make sure you do the composition of functions f of x plus h correctly. Before you get too far, after you set it up, let me come check just to make sure everything's good before you do a lot of work. I can tell. Interesting. And I bet it now part of being frustrated. Alright, let me figure it out. The first one all set up. Let me come check. Make sure it's looking right before you do a lot of work. That'll work. I don't see your issues. Okay, let's do that first together just to make sure we're all on the same page. You should be plugging in x plus h, but our x is what number? 3, so we're going to plug in 3 plus h. So the limit as h approaches 0, we're going to take our f, wherever there's an x, we're going to plug in 3 plus h. So x squared is going to do 3 plus h squared. I see minus x and then minus, but put parentheses, 3 plus h. But we're going to put parentheses minus 2. Are we doing the alphabet x plus h? Minus, I would either bracket this or parentheses, because all of it needs to be subtracted. Meaning the whole f function x squared minus x minus 2. So all of it needs to be subtracted, not just the x squared. We're going to go to the denominator. Yes, thank you. Thank you, thank you. So 3 squared minus, is it a minus? Yeah. And we'll go to the denominator. 3 plus a should be c, and then a minus 3. B minus a, right? Or x plus h minus x. Okay? That's going to be the hardest part. And then carefully go through step by step, yeah? You know you're on the right track if everything that doesn't have an h cancels out. If you have something left that doesn't have an h that doesn't cancel, you made an error. Everything without an h needs to cancel out. Then you factor out the h, and then everything works. No, you're putting 0. You don't put in x, you're putting h. H is 0. And then hit it. Yep. Say, calculus is easy, but the algebra will kill you. The first step is calculus. Everything from math then on is careful algebra. Hmm? That comes from yes, they're very inefficient. Okay, if you're getting a 7, Problem 2, if you're doing first one axis, first and last 2, make sure you distribute the negatives in. Distribute. Those cancel, so we're stuck with the H. H on the back row have minus here. This has goes here. Okay, it's not 6. Final answer? So let's see here. I distributed everything in. And then we find our like terms. Everything should have a cancel except for the H's. 9, negative 9. Negative 3, positive 3. Negative 2, positive 2. All I'm left with was something that's anything with an H. Do you remember that? Okay, now we factor out our H, because every time I'm writing the limit of H approaching 0. Please don't drop that. You won't be doing correct notation. Oh, well, minus 1. Maybe that's what you did. You put a minus 1 when you factor it out? Because H minus H should be 5H. All over H, or H is canceled. So we can finally put it in. 6 plus 0 minus 1 is 5. That's instantaneous rate of change. You have one more before you do have one more page. Okay. Any questions on number 5? Did you find the error if you did it at 5 at the beginning? Okay. Now this one is similar. However, we're not finding the slope at any specific x. We're finding the instantaneous rate of change at any x. At any x. So our answer might not be pretty. We're going to go through the same thing again. So let's write the limit as h approaches what number? 0. Since we don't have an exact value of x, we can't plug in like 3 plus h. So we just plug in x plus h. Okay, so all of the x squared, we're going to replace the x's with x minus h squared. Plus minus x plus h minus 2. That's the first part of the numerator. Any questions about that? X plus h goes in all of the x positions. Minus the brackets and parentheses. Everything needs to be subtracted, and all the x positions we just put x. So it's the same thing. X squared minus x minus 2. That doesn't change much. So the first one's f of x plus h minus the second one is f of x. That's the hardest part. All over, what is the denominator? X plus h minus x. The same thing should happen though. Everything without an h should cancel out. Okay, so let's go through. Make sure that happens. If there's something in B without an h, you're doing something wrong. X plus h squared. You know, can you tell me what that trinomial will be? For this? X squared, the first term, 1. And in between the first and last is x times h times 2. Oh, that was right. So I'll put 2xh. Now the positive h squared. Minus, this is an error we made on last problem. Both of those are minus, right? So minus h minus x. Minus x minus h. Minus 2. Well, for all their possibility to put error right here. Distribute. All of those need to change signs, right? Distribute the negative 1. They all change signs. Minus x squared plus x plus 2. All over the x's cancel. H. Now let's look for things to cancel. Are there any pairs that cancel each other out? X squared. Negative x squared. Anything else? Negative x and negative positive x. Anything else? Negative 2, positive 2. Anything else? Oh, and everything remaining, do they have an each? Yes, so we're on the right track. And then as h approaches 0, you come back down. Now, if you want to save yourself a step, h, and then take out the h of everyone. 2x plus h minus h. Sometimes h, what's that going to be? Yeah, no one way. 2x plus h minus 1. All over h. The h's cancel. What should happen every time? Now we have a division by 0 problem. So we can finally drop the limit and plug in. But which one do we put a 0 on for? The x or the h? The h. So our answer doesn't look as nice as the other one. The answer is actually a binomial. 2x minus 1. Okay? So this is for any point. That is the instantaneous rate of change. So now, what if I said x is now 2? What's the instantaneous rate of change for the same function? Okay, let's just plug in the 2 of that, because this will work for any instant. What if I said x is 0? What's the instantaneous rate of change of the slope at that point? Negative 1. Okay? So that's the slope at any point. Okay, number 7. Find the equation of the line tangent. Find the equation of the line tangent. Okay, when we do this process, we're not putting an equation. What we've been putting is the slope. What do you need to write an equation? 2 things. Slope and a. Because it's a very good lesson. Slope and a point. Thank you. Slope and a point. So we go through this process to find the slope. We actually already know the point. And if x is 3, how do we know the y value? Plug it in. X plus 3 is 3 squared minus 3 minus 2. Exponents first, then we subtract. What do we get? 4. So the point is 3 comma 4. Depending on the point, what's the easy part? The slope is a little bit of a process for instantaneous rate of change. So let's do that. The limit as, what do we write? H approaching 0 of f of x plus h. What is our x? 3 plus h. So whenever there's an x, we're going to insert 3 plus h. Always put parentheses. 3 plus h squared minus 3 plus h minus 2 all over what? 3 plus h to what? To 3. Now, we're going to cheat because we've already done this problem. Does this not seem familiar? It's up at the top. And let's say, is it all the same problem? We've already gone through the process, and then we can do it again. We already know the slope can be solved by using 2x plus 1. When you do all those work steps and you have 2 instead of x, what's the third for x? 3. So what's our slope? Our slope is our n at x equaling 3. But I saw x equaling 3 because there's lots of slopes. But at x equals 3, what's our instantaneous rate of change? 5. Oh, that sounds like number 5. Move it on, I think we're going to do this problem a couple times. So if we have our point and our slope, and the reason our first lesson was about writing equations of lines. We use white limit supposed to be a lot in algebra. But in calculus, we want to use the point slope form. What was that formula? y minus y1, because we have 1 place, so we have y2, equals n times x minus x1. And all you have to do is plug in, and then you can stop. Don't make errors simplify. You don't have to simplify. So y minus 1. Then what do we have? The y squared equals, what's our slope? 5 times x minus 3. That is the equation. You can stop. You don't have to move things around. Just stop. Okay? Number 8 says the exact same thing except for one word. Find the equation of the normal line. I don't know if you've heard that before. Does anyone know a synonym, a math synonym for normal? What? Sort of a P. It's a really long P word. Got it. Perpendicular. And you need to be familiar with both. Sometimes they say normal to the curve at this point. That means perpendicular. Okay? Perpendicular. We know if the slope, this is the same thing, and x is the same. If the slope for the tangent line, this is our tangent line, is 5, what's the perpendicular slope? Yeah, opposite reciprocal, negative 1/5. So what changes in our equation? Does the point change? No, only the slope. So everything is the same, negative 1/5 at first 3. Everything is the same except for the slope. So I put that like normal. So at the very, very bottom, on your own, I want you to write similarities and differences between the front page, average rate of change, versus the last page, instantaneous rate of change. Think about it. Do it on your own first. Think about what do we go over in the front of average rate of change versus instantaneous rate of change. Similarities and differences. So let's write like full sentences, parallel style. Okay, that's cool. Yeah, sure, that diagram. I have to make it big and put words inside of it. Yeah, that's a good idea. If you want to do the diagrams to figure out, that's fine. Yeah. If you have completed that, I get two people correct at the same time. Don't try to hand because it'll just be dots all over the page. But go to the smart board that I want you to write. Similarities and differences. Here are average, rate of change, and here are instantaneous. Yeah, just one up. You can do difference or similarity. Similarity section isn't very large. And I think it's supposed to be two people can be able to write at the same time. So it makes sure the markers are skinny. And your shadow kind of gets in the way, so. You have to go to the top. See where those three lines are? Go to the top. When those three lines are right above your hand. And make sure this came up because when you do the research, sometimes it goes back to the right marker. Yeah, I was actually not today, so I don't know what they're doing that, but they need to re-sync it. Okay, maybe we'll just shout them out. Let's take a look. No, it's just the line is off, so whatever I is showing up higher, the name showing up higher than what they're actually touching. So the line is off. Okay, so one has, the two definitions, right? The definitions are different. Similar, yet different. What's similar about the two formulas? Yeah, they're both essentially like a D minus F of D minus F of A over B minus A. But the difference is instantaneous has limited and H, right? Yeah, that's fine. But something else that's a difference. Averaging the C-stat line over 2 points, right? From this point to this point. Some curve, right? What is the C-cat line? What about instantaneous? And what's the line about at 1 point? Tangent line touches at 1 point and bounces off. Tangent line. Okay? What about a similarity? They're both slopes. They're both, the answer to both of them is a slope, right? I already said the similarity, they essentially have the same formula. Okay? Cool. So, next, how about equivalents? In your book, you can work on, we're on with 2.4. That's essentially with this night. Or you can work on 2.3, that's due next time. So our test will be next Thursday, which will be good because it'll be before the break. And then we might give the test after the break because we pretty ahead. So next class is our review. Everything chapter 2, but the test is cumulative. What does that mean? Everything. So the AP test isn't just going to be in the last chapter of the book, right? Everything. You remember everything. I mean, mostly about chapter 2. You can expect some stuff about chapter 1. But chapter 1 was the review, pre-algebra, trade review, taking a slope in a plane, making an inclusion line, logs, natural logs, that type of stuff.